Hello everyone, welcome to my presentation. My name is Madhuri Bobby. I am a Master of Public Health student from the University of Adelaide, and I've been doing my professional practical placement for the past 12 weeks with Macquarie. As part of my placement, the project that I undertook was the noise exposure among the South Australian mining and quarry industry. To start with, as I started my placement in the month of March, it was important to know that 3rd of March was observed as World Hearing Day. And the World Health Organization provided a guide which was basic and practical framework for any person or organization interested in observing World Hearing Day to raise awareness and promote ear and hearing care at national and community levels across the world. And Macquarie, being one such organization that focuses on health promotion, this project seemed ideal to take. This is a snippet of how the World Hearing Day planning guide looked like that was given by World Health Organization. This project that I undertook, I found it to be useful for Macquarie, especially because one of the key initiatives of this organization is to assess with monitoring high noise and accompanying vibration project, and it also supports and promotes work health and safety education. As I did my research, I found that the last noise report that was done by Macquarie was back on 2008, and therefore I felt that the collected data on noise exposure it can be used for an updated version of health promotion campaign. So, just a basic understanding of what noise is and how it can cause damage. As we know that noise is an unwanted or damaging sound that may damage our hearing and cause other health effects such as stress, hypersensitivity to noise, increased blood pressure, and increased heart rate. The normal range of hearing for a healthy young person is approximately 20 hertz to 20,000 hertz. Hertz being the measure of the pitch or frequency of sound, sometimes referred to as cycle per second. Now, how does this noise damage our hearing? When there's a very loud sound, it makes the hair cell collapse and flatten temporarily, which results in temporary hearing difference. Um, and this is also called as temporary threshold shifts. When this is repeated over many years, the hair cells in the inner ear become permanently damaged, and that causes the permanent hearing loss, or also known as permanent threshold shift. Um, so, what we are doing is raising awareness against the permanent hearing loss. Um, when we come to the mining and quarry industry, we see that noise-induced hearing loss continues to be one of the most prevalent disease in the mining industry. Several factors contribute to the noise exposure of the miners, including confined working space condition, the utilization of heavy-duty mining equipment, and the proximity of machine operators to that equipment. Some of the key points of this monitoring program is that it was used and it was assessing the occupational noise and respirable dust exposure risk for the South Australian mining and quarry workers, which was undertaken throughout the years of 2022 to 2024. One of the main objectives was to determine the occupational noise exposure of workers and associated controls, of which 339 data points were collected and over 43 quarry and mining sites were covered. As Macquarie operates under the World Health and Safety Act of 2012, it's important to understand what the Act and regulation says about the noise exposure, which is that the regulation includes noise level that an employer must ensure workers are not exposed to whilst at work, and these are an 8-hour equivalent noise continuous A-weighted sound pressure levels of 85 decibel referred to as 20 micropascal and a C-weighted peak sound pressure level of 140 decibel referenced to as 20 micropascals. Another key aspect is that the 8-hour equivalent of A-weighted sound pressure is used to assess a person, while the C-weighted sound is used to assess a task. With the 140 decibel, it is mainly a peak, and just one peak would cause permanent hearing loss. When we compare it with the working hours, we see that the permissible noise exposure, that is hours per day, and sound pressure level has a relation. As we know that the regulation states that 8 hours per day, the cutoff is 85 decibel, and as the hours decreases, the decibel number seems to increase. Therefore, just half an hour exposure of 97 decibels per day would be high risk of permanent hearing damage. And in the report, all the shifts that was studied were in the 8-hour cutoff time. Coming to the methodology that was used for this monitoring program, a personal noise exposure monitoring was conducted using a Type 2 H5 wireless personal noise dosimeter to record noise level electronically for the workers. And then that data was downloaded and graphically represented and interpreted for results, after which results were produced. As you see in this diagram, this is what a dosimeter looks like. It was pinned on the worker and it would then interpret the noise exposure level around the worker when different tasks were done. As I mentioned earlier, I adhere very closely to the planning guide given by the WHO as part of the World Hearing Day, of which my phase 2 basically consisted of what I could do or how I could do my project. And this is sort of the step that I had to take to undertake this project. It started with reading of the reports of the monitoring program, matching all the similar exposure groups with the mining activities, um, analyzing the range of 85 decibels and 140 decibels for various activities, then doing a descriptive analysis and giving a pictorial representation through graphs, and finally was locating where most of the mines and the quarry were. So, just to give you an understanding of what SEG or similar exposure group is, a SEG is basically used to make data collection simple, or it gives a hazard characterization. And as you see that each SEG or SEG code is given to sort of the task that is undertaken in mining. So instead of typing driller or drilling activities every time, we could simply code them as seg1, and it is to be understood that that is the task that is being referred to. Um, 23 had other tasks which was not included in the seg, and some of them that I had to include in it were saw operators, weighbridge operators, plant floor operators, etc. I also had to add an extra seg of 25, which was the plant operators, because of the high number of samples that we had. Next was to tabulate all the values for better understanding. So as you see, I have tabulated it in the number of measurements that was taken, the seg that was assigned for the task, and the range of A-weighted and C-weighted sounds to see how many of them were exceeding the noise exposure line. So out of 339 totally, I could work with 190 sample of measurement of because some of them were lost because it was static monitoring that was done, which could not be used for my study, and others were that the dosimeters couldn't pick up the noise rightly. And we see that almost 80 samples were seen to be exceeding the noise exposure line, which is not less at all. It is also important to understand a relative study that is needed to be done. So in our first observation, it is visible that the quarry supervisor and the loader operators had the higher number of exceeding sample. But if we did a relative study, we see that the Quarryman, all the 4 out of 4 had exceeding limits of noise exposure. Therefore, they had 100%, and the plant operator not far behind had 75% of samples exceeding, and drilling and drillers were 60% of sample exceeding, which is why it is easy to be mistaken to think that some of the tasks were exceeding more, but this was simply because these tasks were performed better or much more than the other task, which is why I had to do a relative study to understand it much better. So, talking percentage wise, we have 52% of the miners that were working in various quarries that were found to be exceeding the regulated sound pressure level, of which quarryman and drilling activities have the highest of A weighted and C weighted sound pressure level with 96 decibel and 139.8 decibel respectively. So I clubbed them as A and C and segregated them. And I calculated the mean noise pressure for each of the tasks and tabulated them in 2 separate tables, which after which I represented them graphically. So as you see, I followed the AIOH standard, which suggested that there would be almost certain hearing loss if the mean was much more than 96 decibel, and if the L peak was more than 140 decibel. There would be likely hearing loss if the mean was between 85 and 96 decibel, and if it was greater than 140 decibel. And there would be possible hearing loss if the mean was between 82 and 85 decibel. So this brings us to the graph that I made. And as you see that all the way from quarryman to dozer operator, we have these tasks clearly crossing the line of exposure, while the quarry supervisor and loader operator were not far behind. It is important to know that even though the quarry supervisor to water operator, these tasks were not crossing the noise exposure line, they cannot be pronounced as safe, which is why I use the error bars to sort of say that it is still important to keep check or keep track on the noise exposure that these tasks were being exposed to. In the same way, when we come to C-weighted sound pressure level, we have quarryman leading again all the way to the water truck operator, which has crossed the line of exposure. While the dozer operator to the crusher operator we see is very close to the line of exposure. And especially since we're talking about 140 decibel, the dangers of hearing loss, permanent hearing loss is much more higher, which is why, again, as I stressed for the earlier graph, it's important to know that the task that was not crossing the line of exposure cannot be pronounced as completely safe, and we still have to keep on doing such monitoring programs and audiometric tests on them to see if they are safe from the exposure. Therefore, we come to the management recommendation, which brings us to the hierarchy of control. As we all know that the hierarchy of control contains elimination, substitution, isolation, engineering control, administrative controls, and personal protective equipment. It is important to understand that though elimination is the hardest to achieve among them all, it is the most effective, and PPE is easiest to achieve among them all, and it is least effective. So coming individually, we start with elimination, which is basically just to eliminate the source of noise completely by ceasing to use the noisy machine or process that introduced the noise into that environment, which is basically just removing the task or the source away. The second, we have a substitution. We substitute the noisy machine or process with a quieter one, that is to identify noise emission level at procurement level, which is just before purchasing the equipment. Purchase from suppliers machineries that meet the Australian standard of noise emission. use hydraulic shaping machines instead of impact, handle suspended load with care, that is not doing heavy dropping, use main powered electrical equipment instead of diesel generators, which are much more noisier, to use newer method of cutting, which is the laser and water cutting methods in place of sawing and grinding or drilling, which again is much more noisier. And then we have using hydraulic braking and busting techniques for pneumatic impact for braking methods of demolition. We then come to isolation, which is basically to use enclosure or barriers to isolate the sound of noise from people. Um, so we basically use sound absorbing panel, engine base, and operator cabin. As we see in this diagram, in some of the machines that are used, that is the roller or crane, the operator seat is very close to the engine compartment, which is why the person sitting on the operation seat is much more likely to be exposed to much noise, which is why we use absorption panel or engine base around the engine, which causes sort of an insulating effect. The next is to ensure that the exhaust system are in good condition and the outlets face away from the cabin. Again, coming to the diagram, we see that the exhaust system are very close to the operator's seat, and therefore using exhaust mufflers around these exhaust again causes an isolation effect, protecting the operator from being exposed to much noise exposure. And then certain activities should basically be done remotely away from the workshop. For example, sandblasting, which is considered to be very noisy and can cause much sound exposure. So this is what enclosing in a cabin basically looks like. Then we come to engineering controls, which is basically modify the machine or process to reduce the noise being emitted or control of noise emission along the transmission path. We ensure that the exhaust system meet the Australian noise exposure standards. Um, we control the noise at source, which is maintaining the crushers, crane, and conveyors that they emit lower noise, and especially change any worn out parts. As we know that the maintenance of these machines are very important because older machines tend to produce much more noise. We minimize the number of tasks that is performed at a time. We can also do engineering control through control by design, that is controlling the machine shocks between parts or control of friction or vibration. As we all know that loud radios are played in such mines and quarries, this will only add up to the noise exposure, which is why personal music players is suggested for the workers if they want to hear music and work. But at the same time, they should be educated that the noise in the personal music player combined with the noise of the task that is being performed must not cross 85 decibel. Then we have our administrative controls, which is to do work that is noisy when fewer workers will be exposed, or change the procedures to do tasks in a quieter manner. We educate workers on the dangers of exposure to loud noise, a proper job rotation, which is done periodically, ensure that the maintenance program are completed to schedule and measurement of noise immersion to original equipment manufacturer's value, and to finally ensure regular scheduling of fit testing and automatic testing is done. Finally, we have personal protective equipment, which is hearing protection devices that are suitable to the noise levels. And the two examples for this is earplugs and earmuffs. We see in this diagram there are various type of earplugs and earmuffs that is used according to the noise level that has been exposed. It is important to know that in this program, in the reports, the PPE was the most used among the hierarchy of control. Um, Also, storage, hygiene storage of the PPE is another key point. One must also conduct automatic testing to see if the PPE is working properly. And as you see that an audiometric testing, we have professionals come with the audiometer and the testing is done on the worker. This basically should be done 3 months before the commencement of work, and 2 months, 2 years of regular testing should be done. And finally, training and comfort and fit testing should occur for the earplugs and earmuffs so that the workers can use them in appropriate manner. As a Master of Public Health student, I found it very important, and I want to emphasize on the education of aspect of noise exposure. The reality is that most of the workers is exposed to more than one noise over their various tasks in a day, and the hearing loss will be from cumulative noise exposure, and this also includes when they are heading back home or when they are at home blasting their television or the stereo, which also sort of gives in for the cumulative effect of noise exposure. This only emphasizes how much more we should educate the quarry manager, the quarry supervisor, and the workers the importance of noise exposure and how it can be prevented. Some of the challenges that I faced during the project includes first was understanding the mining activities. As my background, I did not have any understanding of the mining industry or the mining and quarry activities. But for that, I sought help with the work health and safety specialist, Peter William, that work in Makwash, and he was very generous with his knowledge about these activities. And also during our site visits, he showed how these mining activities are performed so I could get a better understanding of how they sort of produce more noise to cause noise exposures. The second was that the similar exposure group were mostly related to dust exposure. An example for that is one of the highest reading that I saw was 144 decibel, which was for the task saw operator, but I could not sort of pin that on the graph because no appropriate seg was given to it, which is why providing a separate seg for noise exposure would be much more better for the further study and to get better understanding. The third was the description about the performed task. So as we saw for both the A-weighted and C-weighted sound pressure level, we had the quarryman, which was leading cause of the noise exposure. But I wanted to have a better understanding of what a quarryman does. Unfortunately, the reports did not contain that. Therefore, a consistent definition of the task in that report would be very helpful for further studies. And finally was the loss of data, which is because some of the dosimeters were not working, therefore not recording, or there was static monitoring done. And for that, I just relied on the existing data. The final part of my project was to assess the location of these quarries. I basically wanted to understand where the quarries were in South Australia. And as you can see that Southern Floral, Adelaide Hills and Maryland had a number of samples that were exposed. And it was crossing the exposure line for both A-weighted and C-weighted sound pressure levels. And I sort of wanted to create a better understanding for Makwash so they could take further monitoring programs and education campaigns in these places. So, the final reflection of my project is that the noise-induced hearing loss continues to be one of the most prevalent diseases in the mining industry. It is a risk that is not talked about as much as the other risk in this industry. We can easily miss this out because we do not see it up much in the news or the big screens. But it is important that the noise exposure should be talked about, especially among the miner and the quarry workers, because as we know that hearing loss is sort of a irreversible permanent damage, and by the time they retire, it affects their quality of life. um, it is also important to educate how they can use the controls in a much better and safer way, and how much more important it is for them to use those controls.